guys. And now at number 9, we see a nice looking circuit theory question on the screen for number 9. Let's read. It says K, L, M, and N are points on the circumference of a circle center O. So giving us the center here, center O. It says XY is a tangent to the circle at K. So this is a tangent at the point K. And angle LKY is 40 degrees. That's right here. Angle between this tangent and this chord is 40 degrees. And angle MKO is 12 degrees. That's the angle right here. We're looking at 12 degrees. All right. And also gave us an angle of 56 degrees over here between this tangent over here and this chord. All right, and remember the rules. I'm not going to go through the rules now. I'm just going to answer the questions. All right, question says find the value of angle KOL and given reasons for the answer. All right, in the work. So they're asking us for angle KOL, which is the angle right at the center here. KOL is right here. All right, so what's the process of finding this angle? What's the chain of thought? All right, let me show you the chain of thought that I would use to find this angle. The thought process. And there are multiple ways to find any angle, guys, but I'm just going to give you an easy one. Eh? So this angle that we want right now is subtended by this chord, which I'm going to mark in red. It's formed by that chord, subtended by that chord. And that chord is making this glaring angle of 48 degrees with a tangent. And there's a rule that says angle between a tangent and a chord right here is half the angle subtended by the chord at the center. So there's a connection of the center rule and the tangent and chord rule, because this chord will subtend 48 degrees at the circumference up here. The same chord. Let's explain it. So this chord will subtend the same 48 degrees at the circumference up here. That's alternate segment rule. So this angle is going to be equal to this one. Angle between a tangent and a chord equals the angle subtended by the chord. So this angle up here is 48 degrees. But it's 48 degrees at the circumference is subtended by this chord, which subtends twice as much at the center, because the angle at the center subtended by a chord is twice the angle at the circumference subtended by the same chord. And so the angle at the center right here is going to be, 2 times this 48 degrees. And so if you kind of connect the two rules, angle at center and angle, an alternate angle, you see that the angle between the tangent and the chord is half the angle subtended at the center. And that's why the angle here is 2 times 48. So when we write the reason like that, so the angle is 40, is 2 times 48. So angle KOL is 2 times 48 degrees, which is 96 degrees. And we're going to connect the two of them and say that angle between a tangent and a chord, angle between tangent and chord, tangent and chord, and chord equals half the angle subtended by the chord at the center. All right, talking about the circle, right? So we can say that. So what we're saying is that the angle here is 48. It is half the angle at the center. And so the angle at the center is 2 times 48, and that's what we did. All right, the angle between tangent and the chord is half the angle at the center. So if the angle between tangent and the chord is 48, the angle at the center is twice that. And so this angle here is 96 degrees. Let's put under that down. Angle at the center here is 96 degrees. This is 96 degrees at the center. So the pen a little bit thinner and write that 96 degrees right here. All right, let's see the next part. Next part down here, it says find the value of each of the following angles, but this one is not asking us for reasons, right? Just one mark for each, so we just need to calculate these angles. Let's write out what those angles are, and then we'll go on the diagram, work them out, and we'll come back and write it. We don't need to put the reasons. So here we need angle LMN, then we need KLO. Let's write them and copy them up. KLO. Then we need MLK, MLK. Then we need KNM, KNM. So those are the four angles we want. Let's just put this on the next page, work them out, and then we're gonna come and put them back down here. So let's paste them over here. We're just gonna work them out, write them in, and then paste them down. So let's just work them out here first. It's not asking us for things. We can actually leave the working note on the screen for the examiner. All right. So the first one I want is LMN. All right, LMN. All right. So I did say that this angle between this tangent and this chord is 48, and so the chord subtends the same 48 at the circumference. So I know that this angle inside here is 48 degrees. This is 48 degrees right here. All right, and that's part of this whole angle that we want. So we need this other piece. All right, so this other piece now is subtended by this chord over here. All right, so that angular other piece over here, inside here, is subtended by this chord. And that chord is making this angle with a tangent of 56. And so the chord is going to subtend the same 56 up here. So I mean that this angle is 56. All right, so we can put that angle inside here is 56. Here is 56. Tangent and chord rule. I'm just going to populate it. That's 56. All right, because it is equal to the angle between the tangent and the chord over there. And the chord is subtending that. So this first angle that I want is the sum of those two, 56 and 48. So let's put it here. This equals 56 plus 48. I'm going to copy it back down. We're done. This equals 56 degrees plus 48 degrees, which works out to go what? Let's add them up here quickly. That's 56 plus 48, 104. This is 104 degrees. All right, so let's do that. The next angle I want is KLO. Let's see where that is on the diagram now. KLO. So K to L to O. That's this angle. All right, so this one is relatively easy because this triangle is isosceles, because those two lines, they are each radii. So that's a radius, they are equal in length. And so we'll complete the triangle with this chord. That blue triangle is isosceles. And we know one angle in it already. And we're trying to find this one. And we can use total angle. This angle is 180. Those two base angles equal. So this angle and this angle here will be the same. And this one is 180 degrees minus the 96 divided by 2, because the two of these are equal. Total angle in that triangle is 180. So we can work this out right here. We can fast. So it becomes a fraction 180 minus 96, and you divide that by 2. Divided by 2, that gives us 42 degrees. 42 degrees. We could have found it another way as well, because we could have said that this angle over here is equal to this one. These two equal. And this one in here is 42. Why is that 42? Why is that angle 42? This angle is 42. Why? Why is it 42? Because the angle between this tangent and this radius is 90. And if this piece of the 90 is 48, then the other piece here must be 42. And then the 42 will be equal over there. So that's another way we could have shown that angle. So we can leave this 42 on the diagram. So let's leave the 42. We're seeing that this angle was 42 right here. All right, so we just calculated. Good. So that angle that we just calculated is 42 degrees. So let's write it here that this is 42 degrees. All right, I'm going to leave the calculation on the diagram here so they will see where the 42 came from. So the next angle they want is MLK. Let's write this better. MLK. So where's that angle? MLK. So MLK now is this angle over here. All right, so let's look at it now. This is 42. If we could find this little piece would be nice, right? But I think the better approach is to come and work in this triangle now. I'm marking out. Now, why is it good to mark out that angle? Because we know that this angle right here has to be 30. This angle has to be 30. Why is it that angle 30? Remember that all of this is 42. That I'm marking out in red now is 42. And the piece up here is 12. 42 minus 12 is 30. So this angle inside here is 30 degrees. And then total angle in that blue triangle is 180. And so this angle that I'm going to mark out in purple now that they want me to find next, this one, is 180 minus those two. So this purple angle here now becomes 180 degrees minus the 48 and the 30. 48 and the 30 in bracket. And so that angle is 180 minus, this is 78. 180 minus 78. The other way is to do it, 180 minus, that will be 78. It's 102 degrees. 180 minus 78, 102. I'm going to verify some of these angles afterwards. Double check it another way. All right. Let's double check it another way. Some of this, just make sure. It's 102 degrees. So this angle that I want is 102. 102 degrees. Right here. Again, I'm going to leave the calculation on the screen. Let's write the answer. 102. The last angle I want is KNM. KNM is up here. Alright, so let me take out these for the blue triangle. Let's remove these. Alright, those. I know I want this angle over here, KNM. Alright, this angle is the next angle that I want. K to N to M, this angle. Now that angle is one of the angles in this cyclic quadrilateral. Right, so these two opposite angles must add up to 180. Just calculate this as 102. So this angle up here, using a cyclic quadrilateral rule, has to be 180 degrees minus the 102 degrees. That gives us back 78 degrees. So the answer here is 78 degrees. And again, I can leave the markings on the diagram as my working out for the answer, but it's 78 degrees. Well, let's check the 78 degrees another way. So it is actually 78 degrees. Let me show you another way to confirm that it is 78 degrees. Let's look at it another way. More math equals better math. So that angle there, this angle here, is actually, if you come back to find the chord subtending it, it is this one. This one across here. So I'm going to mark the chord. So obtaining that angle of 78 degrees that we just got this chord. That chord is obtaining this angle here. Because if you have the angle, you come back to the circle, and come back to the circle on the other side of the angle, you get this chord. That chord is obtaining the angle. Watch this now. That same chord is making this whole angle with this tangent out here. This whole angle. That's the angle between that tangent and that chord, you know. And so the chord, by the alternate segment rule, that the tangent and chord will obtain the same angle up here. What is this angle out here? It is 48 plus 30. See? This angle here is 48 plus 30, which is 78. We did get 78. So that's a confirmation, really, that it is correct. All right, so let me take off some of these irrelevant markings and leave it like that. And then copy these answers down. All right, and place them where they're supposed to go. Just copy it down. But this part didn't ask for answers, you know, so we just needed to show some calculations. They didn't ask for reasons, I should say. So the first one, I'm going to leave it up here. I'm going to move this set down to here, leave a KLO, and then move this one down to here, and then move this one down to there. Let's just put the word angle in front of them. So angle, 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 angle. And that's it. Just make this a little larger. Make this writing a little bit larger. And we are good to go. And that is it. And so that finishes that part of that question. And as I said, I'm supporting those answers with these calculations on the diagram. All right, I can leave those as well. Not hurting anything. All right, then I come down to here now. This now is a bearings question. All right, so I see the north line and it's a bearings question. Question says E, F, G, and H are 4 points on level ground. So the diagram below gives information on the distances and the angles between the points. So all information, angles and distances are shown on the diagram. That's what they're basically saying. So these points is as if you're up in the sky looking down at these points, all right? They're on level ground. That's how it will look from above. It says, show that the value of X is 29 degrees. That's the X inside here. All right, that's what they want us to do. So we're gonna come and we're gonna work in this triangle to find X. What do we observe in that triangle? We know the three sides. We don't know any angle. And once you have a triangle that is not a right angle triangle, where you know three sides, but you don't know any angle, you have to use cosine rule to find the angle that you want. Now remember, cosine rule set up as if we have two sides, an angle between them, and we are trying to find the side opposite. So we set up this cosine rule the proper way. So this is the side opposite and the angle between. So the cosine rule will connect these two across from each other. And you start cosine rule as if this would be an hypotenuse. And these are the other two sides. All right. So it starts out sort of like that. So it starts out like Pythagoras' theorem. So to find this, you have to set up the cosine rule. So we're going to be using the cosine rule. You have to set up the right way. All right, so treat this as the side opposite the angle that we want. So start like Pythagoras' theorem. So this is like the hypotenuse to begin with. So it will be like 6.9 squared if it was the hypotenuse. And it will be equal to this side squared plus that side squared, which is a 5.3 squared plus 11 squared. So that is how we start out like Pythagoras' theorem. But it's not an hypotenuse, it's actually less than an hypotenuse. So we subtract a piece. What is the piece we subtract? It's always twice the product of these two sides which is the 5.3 times the 11 times the cosine of the angle between them, which is the x. And so what we are doing now, we have to transpose this to find the x. All right, so how will we transpose this to find x? I'm going to copy the whole line down and actually animate the transposition. All right, so I'm just copy this down, paste it here, and I'm going to animate the transposition. So what happens is that we want to make this the subject, right? So over here it is negative, so I'm going to transpose all of it onto the right side and make it positive over here, or this side first. And then this term, which is on the right and left side and positive, I'm going to transpose it onto the next side and make it negative. It's coming here. I'm going to put it here for the time being. And so this minus, so all right, so I'm going to put it there. Let me put it where it is, where it will go. So I want to put it right here. And then put this on the right side, this thing, this expression. All right, so if you look at it, this, which is negative, has been transposed over onto this side and is now positive. And this, on this side, which was positive, has been transposed over to this side and is now negative. And then now I need to leave the cos x as a subject. So what I'm going to do next, I'm going to take all of this and divide it on this right side. So I'm putting the line that I'm going to divide it under. And it's as if I take all of this now and I divide it under here. So that's a simple way to show the transposition, right? So that's what we have so far. And then now to move the cos or to find the x, we will take the inverse cos. So the next step will be to take the inverse cos. And so I'm going to shift this away a bit. Or I can leave this line here first and then copy this and show another line. All right, use up the space. So let me just copy this now. Let's copy that, paste it, and show now that we are now taking cos to the minus 1. Shift this all away, and then we're going to take the cos, and inverse it over here. Put minus 1 on it, and we're doing the inverse of all of that, and that leaves x as a subject. All right, hope you all understand that transposition. And when we do this calculation, we're just going to get x. What I didn't want to do is work out each part. You know, it don't make any sense. We just transpose, and so we can do one calculation to get the final value of x. And it's going to be this 29.5, correct 1 decimal place. This is going to give us that. So let's put this now in the calculator. All right, and that's the efficient way to do this thing. Transpose all the terms, all the values, and do one calculation. So it's cos to the minus 1. Let's zoom it up a bit. So it's cos to the minus 1 of this whole expression. So it's a fraction there, and it starts with 5.3 squared. Then we're adding 11 squared. Then we're subtracting 6.9 squared. And then we're putting that over 2 times 5.3 times 11. And there you go. There's the answer on the calculator on this line right there, 29.5. So that's nice when you get a proof and it comes out exact like that. 29.5 correct to 1 decimal place degrees, and that was shown. All right, so it's just the ability to set up this cosine rule and then transpose and make x a subject. That's what we did. All right, that finishes that part. The next part says a vertical tower GT is constructed at point G and pivoted to the ground at E, F, and H using pieces of wire. So what they're basically saying is that, I'm going to take out these markings now. what they're saying is that this point G, they placed a vertical tower there, and the top of it is T, but you're not going to see it. The top of it is T. You're looking from the sky downwards, and it's a vertical tower at G. So like a place a vertical tower at G, and so it's G and T, and they have these points still on the ground around it. So like you have the H there, and the E here, and the F out here, and these points are still on the ground, right? These points, they are still on the ground, and they're connected from the top of this pole with wires. So you have a wire going on to the ground, another wire going on to the ground here, and another wire going down to the ground. So that's a three-dimensional diagram. So what happened though is that the angle between this vertical and this horizontal is 90 degrees, right? So there's a different color to show it. This angle is 90 degrees to the ground, 90 degrees, and this is 90 degrees to the ground back there, and then you also have a 90-degree angle down to this line, right? While this blue thing is vertical, the red lines are horizontal, all right? And it's here. So what are they saying? They're saying we have to calculate, oh, they give us some angle of elevation. So angle of elevation at the top from F is 31 degrees. So from F is 31 degrees. So where's our F? We're saying that this is our F. And they're telling us that the angle of elevation looking up, this is the ground level, you know, angle of elevation looking up is 31 degrees looking up. So let's draw this triangle sort of like an elevation view, and let's really focus. This is the F, and this is the line we're on. All right, so we're drawing this section. All right, so I'm going to draw it like we're looking at it from the side here, as if we're here looking at it this way, this way, this way. The side looking at it this way. This is the eye, and we're looking at it this way. What will we see if we're looking at it that way? Show you what we're gonna see. We're gonna see F and the horizontal ground, and the vertical pole is at T. This will be G T, and the F is gonna be out here, and this is 90 degrees because the angle between a vertical and a horizontal is 90. And this FG distance is 6.9 meters. So this is 6.9 meters right here. And then the angle of elevation, I'm draw it in a different color. Looking up here is 31 degrees. That's what I said, angle of elevation from F up to T is 31 degrees. So that's how it will look looking from the side. If you're standing on the ground and looking on from the side, that's what you would see. This is a vertical tower that I spoke about right here. All right, that's a vertical tower at G, and it is pivoted to the ground with that red line. Pivoted to the ground at F. That's really talking about that. So it's like we're working now in a right angle triangle, which you can copy down to the next page. And I want us to find down here the length of the wire, right? The length of the wire. So let's piece it down here and see. All right, so they're not asking us for the height of the tower this time. Most time they will ask us for the height of the tower, but this time they're asking us for the length of the wire, which we're gonna call X on this diagram. So we can reference it. No, we can't call it X, we'll call something X already on the diagram. Remember the angle was X? Yes. So we're gonna call it L, and the length of the wire, we're gonna call this L. This length is L. And so we're working in this triangle now, so we can use so-called tower. So this is the hypotenuse, and this is the adjacent. So like we're trying to find the hypotenuse, and we know the adjacent. So we set up the so-called tower. One is cos, we're going to be using so-called tower because we're working in a right angle triangle. And what it is that we're trying to find the hypotenuse. I'm going to take the h's, and we know the adjacent. I'm going to take the A's. And so it is a cost trig ratio that has two ticks. So I have to use cost, two sides involved. All right, so find that length L, we're going to use cost. So when I say the cost of that 31 degrees angle of elevation is adjacent, which is the 6.9 over the hypotenuse that we're trying to find, which is the L. 6.9 over the hypotenuse, which is L. And to find the L, we're going to multiply the L and just divide under the cos of 31 to make L the subject. So the L becomes 6.9 divided by the cos of 31 degrees. Now we'll just work this out with the calculator. All right, I'm going to tell them that the length of the wire, we're going to call it L. So I'm going to put equal L right here. So we calculate L down here, they'll know that that's our answer. So it's going to be fraction 6.9 over the cos of 31, and that is 8.05. Give the answer to three significant figures when they don't tell you how accurately you should give it. So it's 8.05 as meters, right? Yes, we're working in meters. And that is our answer. That's the length. If they wanted the height of the tower, they will use tan, opposite and adjacent. All right, so if they wanted the height of the tower, which they normally do, this time they wanted the length of the wire, which in this diagram is a hypotenuse. All right, that's your wire in red. Okay, next part now says, find the bearing of E from H, or the telling us the bearing of E from H is 228 degrees. So I want to put it on the diagram. All right, so always note the from position. So this is from H to E. The bearing is 228. All right, so let's go on the diagram and show it. It's going to help us from H to E. Let's make sure, yes, from H to E. The bearing's at the from position. So let's take these off. Let's put the eye over here to show that that's how we got the diagram, right? The eye looking from this side. So that's what we would see. All right. So let's put on that angle. So it's from H to E. It's E here and this is H. So from here to here, the bearing is 228. So at this from position, this is our north line. And we're measuring the bearing down to A to E. We're taking a clockwise angle. So all of that angle there is 228. All right, that I've marked in red. Let me leave that one, the north line. So that angle there is 228 degrees. 228 degrees. All right. All right, so put in that angle. Remember, we know this angle inside here now is 29.5. And what do they want us to find? Let's see what they want us to find. So let's put on the angle first. They want us to find the angle of H from E. So note the from position again. From E to H, they want the bearing from E to H. So basically I want the bearing the reverse direction, right? So I want from here to here. So if I show this north line, extend it up, just to show the diagram, they are now asking us for this angle from E up to H. So we want us to find this angle in here. So we can find that angle. All right, multiple ways we can find this angle. All right, so let's find it this way. So since the angle around here is 228, and the total angle around a point is 360, and so we can find this angle over this side. It's going to be 360 minus the 228. So we can show that on the diagram that this is 360 minus 228 and get this angle over here. That's 360 minus 228, that's 132. And then these two angles, well, this one is 132 in this one. And then these two angles are what we call co-interior angles. They are angles in a U. That appears to be a U. The angles in the base of the U add up to 180. All right, they're called co-interior angles. So those two angles add up to 180 degrees. And so this bearing angle here that they want is going to be 180 degrees minus this 132 degrees. So subtracting 180, it's 48 degrees. So that is 48 degrees, but because this bearing, you have to put a 0 on it. 0, 48 degrees. All right, that's one way we could have found it. Another way we could have found it, guys, is to do this. Let me show you. Another way we could have found it. It's just okay to want this bearing, right? The bearing of this line, of this direction. Could have taken this line, this direction, and extended it all the way up here. Extended it all the way up there. Right, and then this bearing angle that I want is the same bearing angle here. Same bearing angle there now. It's the same bearing angle. All right, and since all of this is 228, then this bearing angle up here, draw it up here, this bearing angle up here that I want would have been 228 minus 180, because total angle on this straight line here is 180, and everything around here is 228. So this would be 228 minus 180, which is give it a 48 just the same. And if put a 0 on it just the same, so it will be 0.48 still. All right, so maybe that's another way to show you what I found it. All right, so in any case, we can maybe put that one 228 minus 180. Maybe that's the easier way. So this will be 228 minus 180 would give you that bearing angle of 0.48 degrees. So I've shown two ways to do it. Next angle I want is the bearing of G from H. Let's look at it. Make sure you mark the correct angle. It's from H, from the position H to G. Bearings always measure that from position. Just mark it on the diagram and see what angle that is. From H to G. From H to G, yes. From H to G. So it's from here to here. So let's mark that angle in that purple that I want. From H to G will be this angle now in purple. Right here. This angle. Alright, so that one kind of easy because it's subtract the 54. Alright, because remember everything here is 228. And this piece is now just the 228 minus this 54. Alright, that is it. So that bearing angle is 228 minus the 54 degrees here. So that is it. Alright, everything around here is 228. This purple angle is the bearing that I want. It becomes 228 minus 54. So let's mark it here. This angle that I want now is 228 minus the 54. Let's put it like this. Let's put it like this. So it is like that. 228 degrees minus 54 degrees. That's the angle that I want next. 228 minus 54. That's 174. 174 degrees. Alright, so it's 228 minus 54. Alright, the whole thing minus 54, yes. Just double checking. So this becomes equal to 228 minus 54. And we got 174 degrees. Question done. Alright guys, so that ends number 9. One more question to go to finish this paper. That's number 10, starting out with the vectors. But we'll start that in the next video. Okay, see you then. See you then. See you at number 10.